Here's our first setup of a hypothesis test. So let's review our terminology. So HO is the null hypothesis. That's the commonly known claim, right? Something we've always assumed. H1 is our alternate hypothesis. That's our competing claim based on our samples. And alpha is the level of significance. That's the size of the rejection region, okay? Where we place alpha, do we place it on the left, do we place it on the right, or do we place it on both sides? Depends on the alternate hypothesis, okay? Here's my example that I have, some information here. Eventually, we're going to take words and write this based on the words that we get. So you have a paragraph of information, and we'll set this up, okay? So my null hypothesis says mu equals 25. The mean, the population mean is 25. And H1 of the alternate hypothesis, mu is greater than 25. So the alternate says greater than. That means my sample information must be greater than 25. Maybe it's 26. And is 26 far enough away that we think that 25 is no longer correct? Or is it 25.5 and 25.5 is far enough away that it's not correct? That's how we hypothesis test, okay? So since it's on the right side because it's a greater than sign, greater's on the right, less than is on the left, not equal to is both sides, okay? So since it's greater than, it's going to be on the right. So I'm going to mark off about, just guess, about 5% of my graph on the right side. And that whole region we're going to call alpha, okay? Alpha is 0.05. So that's the size of my rejection area. Now this is a normal distribution, so dead center in that normal distribution is my mean of 25, okay? So this line that we have here, we need to find that line. That's our barrier. So any number that ends up, if our sample ends up on the right side of that line in the rejection area where alpha is, we're going to reject. We're going to say that 25 is no longer true. If our sample ends up on the left side of that line, then we're going to say we don't have enough evidence to say 25 is not true. All right, we're just going to keep it. There's not enough evidence to reject it. Okay, so this critical value we'll have to find using our charts. That's a critical value. It will not be tough to do. Okay, so what are my scenarios that can happen here? Well, I can have my sample, and based on my sample mean and standard deviation and sample size, I could end up over here, and that's in the rejection area, right? Rejection's over here when it's right-tailed. I don't reject on the other side. Notice I did not say except. You can't say except in statistics. So with this case A, we'll give it a name A for now, okay? With A, I'm going to say as a conclusion that I'm going to reject the null hypothesis because it ended up over there, right? That's my conclusion. I'm going to reject. Now, if we end up on the left side, which is over here, right? We're not far enough away. And that we don't know what that number is yet. We're going to find it out, but we don't know what that dividing number is at the moment. So if I have a version B where it ends up on this side of the line, I'm going to say, based on my sample, based on my evidence, I'm not going to reject. So I don't say accept, but in stats we just say do not reject. Never say accept. So do not reject the null hypothesis. So those are my two types of conclusions that I can have. That's it. You have two types. You've got reject the null hypothesis. That means it's far enough away. Or you're going to say do not reject the null hypothesis. That means it's not far enough away. It's still in the safe zone. Okay? So everything over here is do not reject. And then everything over here is reject. All right? So we'll figure out the numbers behind that in one of our later videos.